Hi guys, this tutorial is about heats of vaporization and fusion. So these terms sound really complicated, but they're actually kind of simple. Heat of fusion and heat of vaporization. What are they? Well, usually when we think about making something change state, we think about the melting or boiling point. But this is sort of another way to think about melting and boiling. Fusion is a fancy word for melting, and vaporizing is a fancy word for boiling. That's the first thing you have to realize. So a heat of fusion is really the heat of melting. So heat is different from temperature, even though they're related to each other. Temperature is actually speed. It's how fast you have to get your molecules moving, right? So your thermometer is measuring the speed of the particles in your substance. But heat is a measure of the amount of energy that it takes to make the molecules move that fast. And we usually measure energy in joules, or in this case, kilojoules. So let's compare two substances, aluminum and alcohol. This is ethyl alcohol, which is the kind of alcohol we have in our alcohol burners. So look down here at the picture of the aluminum particles. So I have 3 atoms of aluminum in the solid state, and I've drawn double-headed arrows between them, showing that the aluminum atoms are attracted to each other with a pretty strong intermolecular force. Aluminum atoms like each other a lot. They cling to each other. It's hard to get them apart. They're strong magnets for one another. In contrast, alcohol particles are weak magnets for one another. They hold together, but not as well. So I've sort of drawn their arrows further apart and lighter and not as heavy lines, trying to show that even in the solid state, alcohol has a tendency to be hard to hold together. They're like weaker magnets for each other. The effect of this is that if I want to turn these solids into liquids, if I want to melt or fuse them, I need to add energy. That energy will make the particles speed up, we'll be able to measure that as temperature, and eventually that speed will allow them to overcome those arrows of attraction and sort of bend those arrows and allow themselves to sort of slide around one another and turn to a liquid. If I keep adding energy, eventually these particles will actually be able to totally break away from each other despite their attraction for each other, like magnets that are being jostled around so hard that even though they're attracted to each other, they keep coming apart. And that would be vaporizing, turning to a gas. If you look, aluminum has a melting point right here of 2,519 degrees Celsius, which isn't surprising. It's hard to melt metals. You can do it, but you have to get them really hot. The amount of energy you need to add to a solid chunk of aluminum is about 6,600 kilojoules of energy before you can get those particles moving at that speed of 2,519. Ethyl alcohol takes far less energy to start making the particles move fast enough to melt. So heat of fusion and heat of vaporization is the amount of energy needed to change the state of that substance. And it's different for every substance. So heat of fusion is a physical property of a substance. You can tell that it is a physical property because you don't have to chemically change the substance to see the property. Because melting something, remember, or boiling something is not a chemical change. It's physical. The particles move further apart, but they don't change who they're bonded to. So heat of fusion, remember, is the amount of energy it takes to melt something. And heat of vaporization is the amount of energy it takes to turn something to a gas. And every substance has a unique heat of fusion or heat of vaporization, just like every substance has a unique melting and boiling point. And that's it for the heats of fusion and vaporization. See you in class.